chemical hazards and personal protective equipment. In this case, we will touch upon topics ranging from chemical hazards recognition to protection. I'm Si-Hong Lee. You can call me by my English name, Jason. I'm the Deputy Director of the Occupational Health Service at the Center for Occupational Accident Prevention and Rehabilitation, COPRE. I have extensive experience and knowledge in this field. This class this class mostly cover theory, although we will spend a lot of time trying to make it real. The main objectives of this course are the following. Number one, we are going to learn how to recognize the chemical hazards present in the laboratory and strategy of prevention and control, with particular emphasis on the hazards communication for chemical substances and pointers on management of chemical hazards. Number two, we are going to learn different types of personal protective equipment commonly used in laboratory and workplace. Number three, a key goal of this course is for you to familiarize yourselves with how to properly select, use, and maintain and store PPE. The characteristics of laboratory as a workplace. Laboratories are also workplace and are subject to the Occupational Safety and Health Act. But there are several points that require special attention. First, a wide variety of chemical substances are used in significant quantities, which may cause various types of hazards. And second, there is high staff turnover and a complex mix of personnel entering and exiting. And third, the introduction of new research or technological advancements increases risks that are unknown or uncertain. And fourth, laboratories are filled with various high-tech equipment and the working space is limited. What is the safety pyramid? You can call this type of pyramid. And for the safety field, the safety is called the safety pyramid. Safety pyramid, or you can call it Heinrich's triangle, is a visual model that illustrates the relationship between different types of workplace incidents. According to Heinrich's original theory, for every major injury that occurs, there are numerous less severe incidents and unsafe behaviors that precede it. Heinrich research showed that for every one serious injury, there are typically 29 minor injuries and 300 unsafe acts or near miss. The pyramid's main message is clear. By addressing the lower level of the pyramid, such as unsafe acts and near misses, organization can significantly reduce the likelihood of severe incidents. This proactive approach aligns closely with modern EHS strategies. E is for environment, as you know. H is for health, and S is for safety. We can call it EHS strategies, which emphasize prevention, data checking, and employee engagement. This is the outlines of this course. Please refer to this slide for a simple roadmap. Section 1, chemical hazards and their assessment and control strategies. And section 2, we introduce you a few key points in chemical hazards management. And section 3 is an overview of personal protective equipment and eye or face protection. And the Section 4 is respiratory protection. And Section 5 is protective clothing and hand protection. Now let's look at the Section 1. First, we will define hazards. It's very important for us to know something, and the first step is to define something. So you should know the hazard. What's the meaning of hazards? What's a hazard? Any source that may cause damage, harm, or adverse health effects to a person or something under specific conditions. Further explanation is as follows. A hazard can cause harm or adverse health effects to individuals, and for organizations, it can result in loss of property or equipment. There are 5 major types of hazards in the workplace: physical, chemical, biological, economic, and safety hazards. This is the 5 main categories if you want to discuss something about the hazard prevention. Regarding the chemical hazards, toxicity is very important. We should know the meaning of toxicity. Harmful effects caused by exposure and chemical harmful effects. We can see many harmful effects if the doctor diagnoses your health, it can tell you some harmful effects. And what is the cause of these harmful effects? And harmful effects, if we caused by exposure to chemicals through inhalation, ingestion, or skin contact, such as poisoning or tissue ulcers, this is the called toxicity. And hazards is called damage caused by chemicals due to energy released from chemical reactions, such as fire and explosions. This is the classification of airborne hazards. Workplace air can be contaminated by a range of airborne contaminants. They are hazardous when breathed in. Airborne contaminants may occur as vapors, dust, particles, fibers, fumes, or gases, or combination of these. Contaminants can be released into the air when using hazardous chemicals or carrying out work processes such as those involving rotating tool and parts. For example, centers, circular saws, rotors, lathes, or jaws, and hard process. And this is all the work process that can cause many harm to your body. And here we should know the particles. What is the definition of particulates? And the particulates stand for particles or something particle matter, the term for mixture of solid particles and liquid jellies found in the air. Sometimes particles such as dust, dirt, soot, or smoke are large or dark enough to be seen with the naked eyes. Others are so small they can only be detected using an electron microscopy. And so this is the diameter, which is ranging from micro or to nanometer. You can see it, but it's really very harm to your health. And for the right of this pyramid is a gas vapor, and the left is about the dust. It's a liquid or solid. We can see the gas, liquid, solid, free phase of the materials. Here is the classification of airborne hazards. And the airborne hazard can be in the form of solid, liquid, or gas vapor. And the dust is solid particles. And we can everyone, when you go out, you can see the dust, but actually the dust is your normal sense of the pollution. But in here, we need to have a clear definition of the dust. Dust are solid particles suspending in the air. They can be originated from cutting, grinding, or drilling of solid material, and in general are of a size greater than 5 micrometers. Examples include lead dust present in battery manufacturing facilities. And you can see the dust is quite different from your normal sense of the dust. And the dust here, we need to know how it's from. It's from the drilling of solid material, or it's from grinding or from cutting, and so that we can know the way how to prevent it from going out of the work. And the fumes are solid particles made of metals suspending in the air due to heating and subsequent condensation. In general, the particles have a size less than 0.5 micrometer. Why is it so small? Because it's due to the condensation of a liquid form to a particular form. So when the solid particles made of metals suspending in the air, and it's because the air full of very tiny material, and if the liquid phase of the pollutants condense in the very tiny particles, it can form a nearly round size, and it's very small. Normally, it is less than 0.5 micrometers. Examples you can see from your workplace include time magnesium fumes generated from welding works. And forecast of the dust. Dust receiving great attention are biological aerosols, such as those of bacteria, virus, and fungi. Some bioaerosols are capable of entering the lungs at a great depth when inhaled. Why is it so small? Because the viruses are small, and if some water or debit condense in the virus, it becomes a bioaerosol. So it's very small, and when you inhale, it's mostly go into your lung, very depth of your lung. And the liquid particles are generally referred to as mist. Examples include those formed from droplets of lubricating oil used in metal cutting work. If the originating solution is acidic, then the mists are called acid mists, such as sulfuric acid mist or chromic acid mists. Both acid mists are highly corrosive. And for the classification of airborne hazards, another form is the gas molecules. So as we have seen, the dust, the bioaerosol, and also the fume and mist. And finally, we can see the gas molecule is very, very small. It's smaller than those we have seen. Gas molecules possess a significant tendency to diffuse. Because it is so small, it can diffuse, and then eventually occupy the diffuse spaces. Examples include carbon dioxide, ethane, used in welding, and carbon monoxide from combustion, and etc. Vapor consists of molecules evaporating from liquid or subliming from solid due to heating or provision of energy. These molecules otherwise stay as liquid or solid under normal temperature and pressure. So the difference between the gas and vapor are, as we can see from the vapor state, it also comprises of liquid and also the gas. So in the vapor, change between the liquid and the gas. So if you can see the workspace has some ethanol and in a liquid state, we can say that the vapor of the ethanol. Then if we see the gas molecule also is the gas molecule. You cannot see any liquid state in the environment. So this is the big difference, and also the judging strategy for some label inspector. They say the gas state and vapor state is quite hard to distinguish between them, but you can according to some raw forms to see why we can call it a vapor or we can call it a gas. So for vapor state, we can say that some examples including organic solvents used in paints or other commonly known solvents such as benzene, normal hexane, carbon tetrachloride, all have been reported in industrial accidents and some confirmed as carcinogens. So you can see here the gas state for carbon dioxide. You cannot see the liquid state. And for vapor, you can see in here in paints or some solvents such as benzenes. You can see the solvent here. So some molecules evaporating from liquid, we can call it vapor state. This is a case study. We will illustrate this with a case study of a fire and explosion caused by flammable liquids in the laboratory. A graduate student wiped out the spill with a cloth, but the cloth accidentally came into contact with the stove's temperature controller, which may have caused chemical substances to evaporate and triggered a fire. Using previous examples, we introduce a very important concept in occupational safety and health. It's hazard recognition, evaluation, and control. You can call it HREC, hazard recognition, evaluation, and control. Hazard recognition, evaluation, and control is the foundation of an OHS program and is used to identify hazards and manage risk in the workplace. HREC is a set way to make decisions on what could harm workers and how to work safely. It's also an important activity used to get everyone on the same page for what is an acceptable risk and the resources needed to manage them. Step 1, hazard recognition or identification. Find and recall or present potential hazards in the workplace, include all work tasks, machinery, equipment, tools, work practice, and conditions, as well as both routine and non-routine events, such as shutdowns, power outages, extreme weather, and emergencies. And first proceed to this page. We need to give you some introduction about the HREC. And for the step 1, as we've seen from the previous page, is about the hazard recognition. And for this, before we proceed to the control, there's a state evaluation. And the state evaluation is to determine the level of risk posed by a hazard, thoroughly review all available health and safety information, such as safe work practice and procedures. You can see from the SDS safety data sheets. Manufacturers manufacturer's instructions, assessment reports, and legislative requirements. And this is the step 3. This is about the control. Control, what is the meaning of control? Is to reduce the risk of injury or illness happening in the workplace. The hierarchy of controls established that is best to eliminate or substitute a hazard where possible and otherwise reduce the risk using engineering controls or administrative controls. So you can I just mentioned about the hierarchy of controls, and what is the meaning of hierarchy of controls? I do not put it on the PPTs just to give you a roughly view of the hierarchy of controls. The hierarchy of controls is a method of identifying and ranging safeguards to protect workers from hazards. They are arranged from the most to least effective and include elimination, substitution, engineering controls, administrative controls, and personal protective equipment. Often, you will need to combine control methods to best protect workers. For example, a local exhaust system requires training, periodic inspections, and preventive maintenance. You will also need to consider its feasibility. So before we proceed to the control, we need to consider about the hierarchy of controls. It means that the control has many methods. One method is to elimination and substitution. Another method is to do some administrative controls. And finally is the personal protective equipment. So for the first step of engineering control, we should consider the substitution, reduction, isolation, and ventilation. What is the meaning of substitution? It's to replace some highly toxic stock materials with those of lower toxicity. So if you use the more toxic materials to do some work, you should expose to the more dangerous situation. So if we substitute those very high toxicity material, then we should reduce our exposure. And the reduction is to use some less stock material. And isolation is to put it on a box or some place that should prevent those very toxic materials to evaporate into the air and so go to your mouth or your nose. And if we use the ventilation, we can use some local exhaust ventilation or general ventilation, such the air conditioner is a general ventilation to ventilate the air. Local exhaust ventilation is to catch some very toxic material to introduce those material to our workplace to prevent it from going into your nose. But for general ventilation is to dilute the toxic material. So it's a quite different mechanism. And the second step is the administrative controls. So I just mentioned the substitution. This is the second step is to administrative control. And for PPE, is considered to be the least effective method to control a hazard. PPE should only be used when other controls are not practical or adequate as a short-term measure before controls are implemented or during emergency situation. So PPE is the last line of defense. It's not the first priority. The second topic focuses on how to conduct hazard management and hazard communication. Hazard management's core elements include some management leadership, worker participation, and hazard identification and assessment, and hazard prevention and control, and education and training, program evaluation and improvement, and communication and coordination of host employers and contractors and staffing agencies. The best way to prevent injuries or illness in your workplace is to find the hazards that could cause injury or illness and fix them. Do this by following 4 steps. Stop the hazard, assess the risk, fix the problem, and evaluate the results. You can call it SAFE, spot the hazard. A is for assess the risk. F is for fix the problem. E is for evaluate the result. So this is some strategies. And this is for the safety data sheets. Laboratory also usually engaged in chemical disposal operations. And these chemicals must publicly be displayed in the workspace. And the display location should be clearly visible and easily accessible to workers. So SDS is for some document. You can call it the documentation of some chemicals. So the documentation gives you a clear understanding of how the chemicals work to your body. So this is a safety data sheet. Contents of safety data sheet in current display should be confirmed and for accuracy and updated periodically. Records of SDS updates, including content, date, and version, and this should be kept for 3 years. Sections of SDS directly relevant to emergency response include first aid measures, firefighting measures, accident release measures, and exposure controls and personal protection. So this is the safety data sheet is the information to be communicated between the employers and workers, and also to communicate between the manufacturer and the workers. So the content of hazardous material, the information of the hazardous material, should be communicated between the manufacturer and the workers. So the workers don't know how to do some work or how to do some experiment to see the toxicity of the chemical. Yeah, it's a costly experiment. The money should be paid by the employer or should be paid by the manufacturer. They need to know the safety information about the toxic material, and then the information should be passed from the employer or from the manufacturer to the worker. So you don't need to do any work. You just need to know how to read these safety data sheets. So the containers of hazardous material should be you probably many times or every day you can see in the laboratory about the hazardous material the containers, and the containers should be labeled the following instructions from globally harmonized system of classification and labeling of chemicals. This is the GHS system. According to the GHS system, and also in our country, we have include the GHS, the labeling system into our regulation. So it's a word should be, it's the responsibility of employer should label their containers and give this information to the workers. And the tag, the label should be included about the hazard symbol and also the contents, including the chemical name, signal word, and hazard statements and precautionary statements. And from the right, you can see the label. It's a GHS display for benzene containing elements required for labeling. So you can see some pictograms from the top. It's about the fire, about something it can cause the harm to your health, and some other information. So if you work in the laboratory, if you have the chance to use some containers contain some hazardous material, you should be noticed about the labels in the outer package of your container. So this is about the SDS safety data sheet. It includes 16 sections. So you don't need to know all the 16 sections. You should just notice some very important points. And here you just need to know what is the first identification, and second is the hazard identification. Third is the composition information and ingredients. And four is first aid measures. 5 is firefighting measures. 6 is accidental release measures. And 7 is handling and storage. 8 is exposure controls and personal protection. And another 9 to 16 is for physical and chemical properties, stability and reactivity, toxicological information, ecological information, disposal considerations, transport information, regulatory information, and 16 is other information. For us, when we work in the laboratory, we should know about the 9 and 10 and 11. This is 9 to 11 is the most important sections you need to know. So if you have the chance to work in the laboratory to handle some chemical materials, you need to notice about the safety data sheets and include all the 16 sections of safety data sheet. You need to particularly take a notice about the 9 to 11 sections. From GHS, we have some requirements for hazard labeling, and the labeling of hazardous chemicals in containers of a capacity over 100 millimeters should follow GHS format and include 6 elements. Just let me to read through these 6 elements. First is the pictograms for major hazards. Second is name of substance or ingredient. Third is signal word, danger or warning. 4 is hazard statements. 5 is precautionary statements. 6 is supplier ingredient identification. And for containers with a capacity less than 100 milliliters, why we should have 2 requirements for hazard labeling is because for 100 capacity over 100 milliliters, you can have more space to put the label on top of the container. But for a smaller container, you don't have any space to put a label So we reduce the elements from 6 to 3. And for these three elements, it's more important for you to know. And also, we should know for this capacity less than 100 milliliters, the dangerous is not so dangerous from capacity over 100 milliliter. So we just put a few elements on top of it. Is kilograms for major hazards, and 2 is the name of substance, and 3 is about the signal word. This is the picogram. So as you can see from the top, the picogram is very important. So for the capacity over 100 milliliter and for the capacity less than 100 meter, we should put picogram first. Why is so important? Is because that is very is on the top of this, and you can very easy to see the toxicity or any information from it. Is the picogram for you to know. So for this picogram, I think it's very important for student to recognize and to know it. Is because it's about your safety. And for this picogram, this is health hazards. It includes carcinogen, mutagenicity, and reproductive toxicity, respiratory sanitizer, and the target organ toxicity, aspiration toxicity. And for this frame, you can see the frame. It's a flammable and it's a self-heating and it's a self-reactive organic peroxide. And this is an exclamation mark. It's not so dangerous, but you should also notice it. And for this gas cylinder, you can see the kilograms. You can see the cylinder's mark. So it's very easy for you to recognize it. It's a gas under pressure. And for this is for correction. You can see a hand here. You can see some gases here. So it's just when your hand to touch all these liquids is very corrosive. So this is the picogram is to symbol you about the corrosion of the material. And this is explosion here. So it's an exploding bomb. It's something about the dangerous of explosion. And this is the oxidizer. So this one is called the oxygen, and this is the fire. So it's the oxidizer. So it's very easy for you to know. And this is the some fish, some tree, some water. So this is the material which is harmful to the environment. And this is skull and the crossbones. So it means it's a acute toxicity. So according to the OSHA is American Occupational Safety and Health Administration. So all our information and our rules is mainly come from the American OSHA. So we usually to read some books to talking about the OSHA. So we should know the meaning of OSHA. So for some storage of chemicals, OSHA says no more than 25 gallons of flammable or combustible liquids may be stored in a room outside of an approved storage cabinet. Additionally, OSHA requires no more than 60 gallons of flammable liquid can be stored in a single chemical storage container or warehouse. OSHA also requires some rated storage safety cabinets when possible. So when we talk about the storage of chemicals in a room, so we need to put some hazardous material in an storage cabinet, and the storage cabinet is ruled by the OSHA. It should be is something about the 20 gallons of flammable or combustible liquids. When we have some chemical liquids, it's flammable or combustible, and it's over the 25 gallons, we should store in an storage cabinet. So this is the storage cabinet. So you can see the gas cylinder in here, and the storage cabinet should be equipped with hydrogen detector. And so for the hydrogen, this cylinder is the hydrogen detector. You can see the color is red. So if you see a red color cylinder, is hydrogen. So in this cabinet, we need a hydrogen detector and also an alarming device. This is the ventilation equipment. When we handle some samples containing microorganisms or airborne capacity, should be processed and handled in the biosafety cabinet. And ventilation hood for chemical possessing and biosafety cabinet for handling microorganisms are different in functions, and the ways they function don't miss it. So if you use chemicals, you should put it in a hood. So if you use some biosafety material or some bioaerosols, you should put in a biosafety cabinet. So the biosafety cabinet and the chemical hood is quite different. So the functions are different. So when we discuss about the ventilation equipment, we should see the transport velocity. And what is the transport velocity? It refers to the air velocity to transport particles and prevent deposition within the duct, which could be a fire or explosion hazard. Where ducting is wrongly sized, the transport velocity within the duct may be insufficient, and contaminant will settle out in the ducting. This can be a serious fire hazard if combustible or inflammable contaminants are being extracted. The flow rate of air through the system must be sufficient to achieve the initial capture contaminant and carry all contaminants to the purifying system. Combustible dust, if not extracted properly, can deposit in the ducting and be a fire or explosion risk. Flammable solvents being captured by the system need to be diluted by sufficient air flow to prevent formation of flammable mixture. So the ventilation equipment should focus on some points you should remember. And we can see the first is toxic gas. So when it is released from scientific equipment during its operation, the point of gas emission should be covered in local exhaust system. So the local exhaust ventilation, we should call it LEV. So is to catch the pollution from the source and to be transported to the purifying system. So the LEV ventilation hood and release equipment are required to be annually checked. And how to stop when we how to check this ventilation equipment? If we see some damage in those pipeline, or a normal operation or driving motor, or blocking of filtration device, or any other signs of abnormality, we should ask someone to be your laboratory to check and repair the ventilation equipment. So this is the gas cylinders, as you have seen from the previous 2 pages. So if we see the red size is about the hydrogen. So when using a high pressure gas cylinder, we should observe the following key points. First, is the gas cylinder securely fixed in a horizontal position? And the second, are there any flammable materials inside the gas cylinder or storage room? And the third, is the gas composition inside the cylinder clearly labeled? And the fourth, is there any leakage at the connection point? And the fourth, is the storage room temperature above 40 degrees Celsius degrees? So this is the main points you should observe in the laboratory. And for the empty cylinders or those unreserved, it also should be kept. This is the kept. So if you handle some chemicals, you should not leave a range unseen the regulating valve. This is for hazard communication and chemical labeling. So do you remember the scope and crossbone symbol we saw when introducing hazard communication? So this is the scope, and this is the 2 crossbones. So this is the chemical, is the pictograms and your SDS or your chemical labeling. It indicates acutely toxic chemicals. Using this as an example, when the laboratory uses acutely toxic chemicals, how should we properly manage the associated risks? So here we just talk about the pictograms. You can see the skull and crossbone. It refers to the acute toxicity of the chemicals you handled. And if you see the containers, you have seen the labels. So you should notice about is the something about the acute toxicity. So this is the laboratory waste. So as you mentioned about the container, you don't see any labels above it. So it's not a good storage form. It's not a good example. Arbitrary disposal of laboratory waste, including those of radioactivity, toxicity, corrosivity, and inflammability and infectious nature, may pose a threat to health of those who work in the laboratory as well as to the environment. So, an arbitrary disposal of laboratory waste is subject to lawful punishment. So, what is waste? What is the toxic material? So waste is also a toxic material. It's harmful to your health. So don't just think it's about the waste. So you don't need to take care of it. It's wrong. It's not a good idea to just to ignore it. We should also take it in our mind. There is also something which is harmful to your health. And the collection, classification, labeling, and storage of laboratory waste, and the transfer of waste to the management unit for temporary storage and final shipment for disposal should abide by the Institute's regulations. So according to the school's regulations, so if you see the containers which is harmful, you need to put some labels on top of it. Otherwise, you should should be subject to some lawful punishment. Next, we will move on to our third topic. It's a general instruction to personal protective equipment and eye face protection. So the protective equipment and so the personal protective equipment. So it's the PPE. This is the last line of protection. As we have seen from the previous pages, we talk about the hierarchy of controls, and the PPE, personal protective equipment, is the last line of defense. It's not the first priority, it's the last line of defense. So, and here I must emphasize that personal protective equipment should only be used as a control measure when other measures are inappropriate or are inadequate by themselves. The person undertaking a risk assessment must exercise his or her judgment to take into account the protection afforded by the PPE. There is therefore considerable scope for difference in approach, and it would seem sensible to eliminate these differences and ensure consistency, where possible, by reaching agreement on the attenuation effect of PPE. So you should keep in mind the PPE is the last line of defense. It's not the first priority. So if you want to use the PPE, you should do some risk assessment and to ensure it's actually follow the good instruction of the risk assessment, and then you can use it. So when introducing personal protective equipment, the first and most important point is to strictly distinguish between the use of PPE in emergency and non-emergency situations. So the emergency, you can use the PPE, and the non-emergency situation, you can use the PPE, but the two scenario is quite different. You should keep in mind, you should first to distinguish between the emergency use or non-emergency use. In emergencies, saving lives is the top priority, and the long-term health effects are often overlooked. Here, we will only discuss the selection of PPE for non-emergency situation. So for the emergency situation, the save your life is the first priority. And for non-emergency situation, you can use the PPE. It's just because we only discuss the long-term health effects, not discuss about the safety. So for the here are some types of PPE for non-emergency use. The first is the eye and facial protection, and respirators, and chemical protective clothing, hand and foot protection, and hearing protection. PPE can protect you only when you use them. Many PPEs were bought displayed in the safety equipment cabinet and never used. You can see from your school's laboratory, some PPEs are being put in the cabinet and never been used. So when you find it, there's full of dust over it. So it's not good. If you want to use PPE, it should be used. And PPEs may bring you more harm than safety when they are improperly used. PPE have to fit the user's anthropometric characteristics such as the body shape, body size, and even facial characteristics in order to be protected. So you have some beard. If your nose is very high, or if you put some goggles in your or some glasses in your face, it also protect you. It also make you very hard to put on the PPE. So you need to consider about the personal characteristics before you use the PPEs. The risk of exposure to toxic substance when using personal protective equipment may be greater than when not using it. For example, when the skin is moist, such as from heat or from sweating, which is caused by wearing protective gear, the amount of chemical absorption through the skin is typically 1 to 2 orders of magnitude higher than expected. So if your skin is moist, then some chemicals may be very easy to go into your body, go through the skin, and it's just because your skin is moist. So then the particle, the material should be very easy to go into your body, and this is the amount of the dose should be 1 to 2 orders of magnitude. Here is some information from laboratory safety and health essentials. So for safety glasses and lab coat, the top row is a good example, and the bottom row is something very is not good. For some, you need to put some glasses, and you need to put some lab coats, and before you do the experiments, the glasses and lab coats should be all be prepared for you to wear. And this is the closed shoes. So this is the case closed shoes. So you can see some frontiers should be closed. And this is the open shoes. So the frontier of the toes of the toe is the outside the shoes. This is the eye and facial protection, and you can see some example. So these protective gears were not in place. You can see if this is your eye, something will be go through it, and this is the shield. You can see some rupture in the shield, and this is the eye. You can see something, and this is very not good consequences. And for regarding eye and face protection, let's first take a look at the factors in the laboratory that can easily cause injury to the eyes and face. The column on the left represents the types of hazards, and the column on the right represents the possible types of operation related to those hazards. Damage caused by impact. We should consider about the higher risk task, and then for workers, it will be when they are doing all these tasks, they should be consider about the danger of some hazard type, such as the impact. So for the impact scenario, the high risk test is about the cutting, slicing, grinding, sculpturing, and any other tasks producing objects or debris capable of flying with sufficient momentum. And for heat, operating high temp furnace, oven, or melting welding work, and any other tasks producing high temperature. So here we call this hazard type is about the heat, not the temperature. And why? It's because the temperature should be higher than 37 degrees or lower than 37 degrees. And for temperature higher than 37 Celsius degree, then it is dangerous to your health. But actually, our body can manage it. And for the temperature higher than some circumstances may be dangerous to your health. And for temperature lower than your about 37 degrees Celsius lower than your body temperature, you will feel cold, but sometimes it's not very dangerous to your health. You can see from some countries which is maybe the temperature is very low, but actually they are used to it. So it's not very dangerous to your health. So when we talk about the heat, is about the temperature higher than your body temperature. And for chemicals, it's a handling and treatment of chemical or some specimen. And for dust, it's for about some woodwork. And for light, it's about welding, melting, and cutting, and laser operation. So we know the hazard type and also the high-risk task. When we conduct some high-risk tests, we should consider about this situation, and we should know about this hazard type. And about the eye and facial protection, so we need to take some safety glasses, and the safety glasses is some barrier to protect your eyes from something material outside the safety glasses. So it's a barrier, it's a protection. So this barrier is a mechanical barrier to bury some energy, some flying objects to contact your eyes. So this is so for the safety cases, we should consider about the mechanical harms, and the mechanical harms is about the flying objects and spill liquids. This can the safety cases is a barrier. And for radiation, the safety cases can also is a barrier, but this barrier is for some coatings outside the safety glasses, and this coating can barrier some ultraviolet and visible light radiation. So this is the safety glasses, and in the middle column is a goggle, and for the right column is a face shield. So the protection in these three types is quite different. So for these safety cases, it's not the protection is not very big. For the goggles, the protection is in the middle situation. So here is the welding face shields and helmets. Is to protect against light of high intensity. So the light filtering lens you can see is a very it has different colors, and these colors can acting as a barrier to protect your eyes. As for eye and face protection, I would like to talk about contact lens first. And wearing contact lens is prohibited as the most conservative intervention approach. So it's not good for you to wear contact lens in a laboratory. Basically, it's prohibited. It's because contact lens is near to your eyes, and it's not like the glasses. It has many shield or any outer mechanism can prevent your eye from contact with the material. And second, evaluating risk of using contact lens is a must do. And third, using airtight goggles for additional protection if you must use contact lens. So for you, if you wear the contact lens, so you should take three main points in mind. First, this is the most conservative intervention approach. It's not the first priority. Actually, contact lens can afford you none can afford you nothing about the safety. So it's prohibited. And for second, if you still want to take the contact lens, wear the contact lens, you must evaluate the risk about it. So it's a must-do situation for you to evaluate the risk of using contact lens. And the third, if you still need to use your contact lens, you need to use airtight goggles for additional protection. So this is something about contact lens. This is additional information about the contact lens. The contact lens are prohibited in the laboratory just because the reflective shutting of the eyelids when foreign objects enter makes removal of contact lens difficult. So anything go into your eyelid, it's not very easy to remove the contact lens. So the contact lens maybe to stick to your eyeball. And the second, some chemical in the form of vapor are capable of permeating through the lens and interacting extensively with ocular tissues due to occlusion effect. So if the vapor and contact with the contact lens, something will happen, and it's not very easy for you to know how the chemical reaction is, and it's not easy for you to remove your lens. So and the vapor and can also accumulate between the lens and your eyeball. So the accumulate of this vapor can cause harm to your eye. And the long-term use of contact lens may reduce sensitivity of cornea and secretion of tears, and thus weakening the eye's natural defense. So what is the natural defense? The tears is the secretion of tears is a natural defense. So if you wear the contact lens long enough, the secretion of tears is prohibited, or sometimes the secretion of tears will reduce its amount, and this amount, the reduction of this amount can weaken the natural defense. Next, we will introduce our main highlight: respiratory protective equipment. So this is very important in personal protective equipment. So as you can see from any course introducing the PPEs, the respirators is the first and most key points. Respiratory protective equipment can be categorized by function into two main types: dust masks and gas masks. So talking about the respirators, so the first step is to distinguish about the dust and gas. So for dust and gas, the removing mechanism or the filtration mechanism is very different. So the function of a dust mask is to remove solid or liquid particles. Its mechanism of action is to use mechanical methods and filter materials to capture suspended particles to protect users from the risk of exposure. And please refer to the following diagram. Dirty gas enters from the left. So this is the, if we see in the box, this is the dirty air. So this is the filter material, and this is the clean air. So the dirty air enters from the left, passes through the filter material in the middle, and finally becomes clear air and flows out from the right. So this is the mechanism of the respirators. So the key points is about the filter media. If the efficacy of the filter media is very good, then the dirty air should be clean almost 100% to become a clean air. So this is, you can see from the electron, some photograph of the respirators. So filtration of particulates by fibers and aging effect for mechanical filters. So you can see the used fibers. It has many dirty things attached to it. So this is a clean fibers. It's very clean. But if you see from this photograph, the dirty material attached to the fibers, so the space between the fibers has reduced. So it's because the dirty things, the space is reduced. So the efficiency of the respirators is increased. It's just because the space is reduced, the capacity is reduced. So if the more dirty of the filter material, the efficiency is increased. So filter material, so the dirty air can pass through the space between the material to be here. But if the space is the capacity, the space is reduced, then the particle should not be very easy to go through this reduced amount of space. So this is the gas mask. Gaseous harmful substances generally use specific substance. Specific substance should be filled in filter canisters. And this specific substance is to absorb or catalyze reactions in the gaseous molecules, filtering out the harmful gaseous molecules and allowing clean air to enter the respiratory system. And the absorption refers to the phenomena in which gas or liquid molecules adhere to the surface of an absorbent. Absorption and absorption. So absorption is ADSORPTI1, absorption. And the second is absorption, ABSORPTI1. So for the absorption, ADSORPTI1 absorption, it refers to the phenomena in which gas or liquid molecules adhere to the surface of an absorbent. And for absorption, ABSORPTI1 absorption, it refers to the phenomena in which gas or liquid molecules penetrate between absorbent molecules and are retained in the absorbent by chemical absorption. So for the absorption, ADSORPTI1 absorption is to for gas or liquid to adhere to the surface of an absorbent. For absorption, ABSORPTI1 absorption is for gas or liquid to penetrate between absorbing molecules and are retained in the absorbent by chemical absorption. So absorption is to adhere, absorption is to absorb. So this is the different molecules. And for the catalyst, it refers to the phenomena in which the rate of chemical reactions of chemical substance is affected by catalyst. So for this gas or gas molecules, so it reacts with the catalyst and changed into another state. So this is to retained by the respirators. So this is for the catalyst. So before we talk about the gas mask respirator, we need to know about the mechanism for them to remove the gas. And the mechanisms include: one is absorption, for the gas to absorb to the surface of an absorbent. Second is the absorption, for the gas to be absorbed by chemical reaction of absorption. And the third is the catalyst, and the catalyst refers to the chemical reaction between the gas and the filled material in the canister. So this is the first mechanism about the gas removal. So in the canister, we can have the absorbent for organic solvent. So if the organic solvent for the air, including organic solvent, is passed through the canister, you will pass through it, and the most part of the organic solvent will be retained from the frontier of the canister and then become clear. So this is the change gradually from the left to the right. So you can see from the graph. So the concentration is very high from the left, and the concentration becomes low from the right. So this is the graph of the canister. And here, as the canister, as the time goes, the concentration become reduced. So all the canister, most of the canister will be filled with the organic solvent. And for here, almost entirely, so the organic solvent will be absorbed by the canister. So the graph is shown here. So this is the microscopic of the mechanism. You can see the pores in the canister, and the organic solvent will be go through the depth of the canister, of the filter. So then will be removed by these pores. I believe everyone is familiar with N95 N95 mask. They are disposable dust masks. So for the N95, it's very famous, but you should know that it's disposable. So whenever you use it, you need to dispose it. So it's not for you to use for a long time. It's just for you to use in some situation, and when used it, they should be disposable. These two types are dust masks with replaceable filter cartridges. So as you can see, it's not a disposable respirators. This is disposable respirators. This is not disposable respirators. So the dust mask, the replaceable filter should be put in the cartridge and should be attached to the mask. So this is the replaceable part, and this is the replaceable part. So for the particular respirator, the disposable part should be put some filter cartridge. And the inside of the mask is under negative pressure. Why? Why is under negative pressure? It's because you breathe the air, and when you breathe the air inside the mask, it becomes a negative pressure. And gas mask, you can we also can be categorized into two types. One is half face piece, and another is full face piece. So this is the half face piece. It covers about from your nose to your chin. So this is a half face piece respirators. And for the full face piece respirators, so it covers all your face. So it's a full face piece. And this is half of your face. So this is a half face piece. And this is the full face piece. And also this is the replaceable part. And from previous page, the replaceable part is a replaceable face piece. And this is for dust. And here, the replaceable piece is for gas. And air is driven by the negative pressure inside the respirator. How to select the appropriate respirator and level of protection. So when you select a respirator, employers and RPP, so we should is a abbreviation. It refers to the Respiratory Protection Program, RPP, Respiratory Protection Program. So when employers and Respiratory Protection Program, RPP managers, should consider the hazards present and understand the different protections each air purifying respirator type can provide to make a proper selection. So for the RPP managers and for the employers, they should consider the hazards present and also should understand the protection afforded by the respirator. And when the hazards present and the difference protection provided by the PPE, the respirator, the difference is the risk. So you should, for the managers and employees, they should know the gap between the hazard presents and the prevention of a respirator. So the prevention of the respirator and the hazard present, the gap between them is the different, very important issues that the employers and PPE managers should be understand. So the difference between them is the protection factors. OSHA provides an assigned protection factor for each respirator case. APF, assigned protection factor. So APFs indicate the level of protection the wearer can expect it to receive from a respirator when the wearer is properly fitted and trained. The higher the APF, the greater amount of protection the respirator can provide to HCP. So the level of protection provided by respirator, you should know about this, the level. And you should also know about the hazards present. So the hazards present and the level of protection, the gap between these two is the manager should be understand. So you need to know about the level of protection. And the level of protection is assigned by OSHA, is the APF, is the assigned protection factor that each respirator can provide. So this is a concept. So we need to know the level of protection is from the surgical mask to the self-contained breathing apparatus. So the protection level is increased from the left to the right. So for the surgical mask, it affords nearly no protection. And for the self-contained breathing apparatus, it provides the full protection of the hazards. So you should N95. So the N is coming from here. So this is the classification of particular respirators by U.S. National Institute for OSHA, or Occupational Safety and Health. So National Institute for Occupational Safety and Health should be abbreviated as NIOSH. So it's a NIOSH. NIOSH is commonly called by industrial hygienist. NIOSH is a research institution in the United States. So they do some experiment for the respirators and give you the serious names. Should give why they should it's just because they need to give you the level of protection. They should give you this diagram for you to choose. So they categorize some level of particular respirators and according the 3 series NRP, they do some experiments for the respirators and give you the records for you to choose. For the N series, stands for no oil is present in the air. So the R stands for oil is present, and the P stands for oil is present but follow the manufacturer's time use limitation if you want to reuse this. So just to give you a few introduction about the NRP. So NRP are NIOSH certification categories that apply to negative pressure air purifying respirators that protect against respiratory particulates. But particulate respirator will have an NR or P designation along with an efficiency rating such as 95, 99, or 100. Some examples include N95 and N100 disposable face piece respirators and a P100 cartridge. Please make note of this designation as you may make your selection for the respirator suitable for your job task. N stands for, as I just mentioned, N stands for no oil is present in the air. R stands for oil is present, but only for a single shift or 8 hours of continuous or intermittent use. So oil is present, but only for a single shift or 8 hours of continuous or intermittent use. And P stands for oil is present, but follow the manufacturer's time use limitations if you want to reuse this. So this is the how to select respirators. So you need to follow the 4 key points. Type of respirator and level of protection required. So this is the type. This is the type of respirator. And this is the level of protection. So need to take a notice of the type of respirator and the level of protection required. And second, not everyone can use the same type of respirator. So why? It's just because personal characteristics is very important. So if you have a big nose or if you have some beard in your face, and the respirator, the efficiency of the respirator should be affected. And third, level of reduction in contaminant concentration by the respirator. And we need to know the efficiency of the respirator. So you can know you can see the difference between the hazards present and the difference about the concentrations behind the barrier. So you need to know the hazards present, and you should know the filter media, the efficiency of the filter media, and you can know you can know how clear is the air. And this is the partition factor and the fit factor. If the following special circumstances occur, such as the inhaled air is unsafe, such as lack of oxygen, or the inhaled air may be contaminated by toxic substances, only air supply respirator can be used. And why? Why in this situation we can only use air supply respirator? We cannot use any other types of respirator. So we can go back to our first diagram. Sorry. It's quite. Sorry, I cannot find it. But I just want to let you know that it's because that when we entering and when we first begin our course, I give you a concept about the emergency and non-emergency. So for the emergency use and for the non-emergency use, the situation is quite different. And it's just because the situation is different, it will affect the choice of your respirator. Why? It's because when you are in an emergency situation, the safety is the first priority you need to consider. And for the non-emergency situation, you just become to you just going into discuss about the long-term effect. So for emergency situation, the consider points is quite different from that of a non-emergency situation. So when emergency situation, so it is this in here we discuss. We need to understand an important concept. What is IDLH? IDLH. So it is an emergency situation. So when you are in this emergency situation, the only respirators you can use is the air purifying, air supply respirator, not the air purifying respirators. So we need to know about the concepts of IDLH. So when I just to mention it again. So when you are in an IDLH situation, the only respirators you can use is the air supplied respirator. When you are not in the IDLH, you can use the air purifying respirator. It's the different situation. So when you are in an emergency situation, such as the IDLH situation, you can only use the air supply respirator. When you are not in an emergency situation, or you are not in an IDLH situation, you can use the your air purifying respirator. So IDLH is a facial concentration developed to prevent acute toxic arising from inhalation exposure to hazardous material. When exposed to a toxic chemical at concentration beyond IDLH, a person may suffer death, irreversible health effect, or loss of ability to escape. So when you see here, the death, irreversible health effect or loss of ability to escape. So this situation is something about the dangerous, the emergency situation. So when you are in an IDLH situation, you can only use air supply respirator. So oxygen content, why is so important? Is because when oxygen concentration is less than 6%, the man can die. So this is the emergency situation. So the oxygen content is very important. So the Earth's atmosphere is mainly composed of 78.1% nitrogen, 20.9% oxygen, and 0.9% argon, and 1 to 4% water vapor. So this is the atmosphere content. So almost all living organisms require oxygen to breathe. For humans, an oxygen concentration below 18% can affect physiological functions, and a concentration below 6% pose an immediate life-threatening danger. So just going back to our here. So when a reservoir air being unsafe to air, such as insufficient oxygen content, or being contaminated by a hazardous material, such as the acute toxicity material. When in these two situations, you need to use the air supplying respirators. So what is the protection factor? So to evaluate the overall protective effectiveness of protective equipment, we should refer to its protection factor. The protection factor is defined as the concentration of contaminants outside the mask divided by the concentration of contaminants inside the mask. So it's the ratio between the concentration outside the mask and the concentration inside the mask. The concentration of contaminants inside the mask depends on two factors: the filtration efficiency of the filter material and the degree of leakage through the mask facepiece. The filtration efficiency of the filter material is tested using standardized method, while the leakage of the facepiece can be assessed through fit testing. So the two factors affect the concentration inside the mask. One is filter efficiency and one is facepiece leakage. So the filter efficiency can be tested by some filter efficiency test methods, such as 42 CFR Part 184. This is the American regulation. And for the EU, EN is the 149/2001. And for the CNS, is Taiwan's standard, is 14755Z2125. So this is the methods to test the filter efficiency. And another factor affect the concentration inside the respirator is the facepiece leakage. And for the facepiece leakage, you can use some fit testing methods to test the leakage. Because the filtration efficiency is nearly 100%, so the filter efficiency. So here, you can see from here, the test method, you can see the efficiency of filtration is 99.7%, 99%, 95%. So it's almost 100%. So for the filter efficiency is almost 100%. So the most determinant important part goes to the phase piece leakage. So this is 100%. So this becomes the most important part. Okay. So because the filtration efficiency is nearly 100%, the protection factor is almost equal to the fit factor. It's almost equal to the fit factor. So in here, so the protection factor equals to fit factor. Why? It's because the filtration velocity efficiency is reaching 100%. This table shows the fit test results of several commercially available masks. We can see that the fit test for regular surgical masks can never reach 100%, and the fit test results for N95 masks are also not ideal. The main reason is the significant variation in facial structures among individuals. So in here, you can see the surgical, we can, so in here we can see the surgical mask, the is not good. And for the N95, it's not ideal. The main reason is that just here, protection factor equals to fit factor. Why? Filter efficiency is almost 100%. But the key point is about the fit testing, is about the face piece leakage. So although the N95 is efficiency is very good, but actually the protection factor is not ideal. Many common types of respirators are tight-fitted. It's a negative pressure when performers rely on a good seal between the respirator and the worker's face to minimize the risk of exposure to airborne contaminants. So people's face vary significantly in size and shape. So it's important that a tight-fitting respirator is a suitable fit for each worker. Fit test detects for air leaks around the seal between the respirator's facepiece and face of the worker. If there isn't a good seal, contained air will leak into the respirator and the worker may not get the level of protection that is needed to protect their health. So we need to check the fit situation. So we come out fit checking. So each time when a tight fitting respirator is put on, the worker should carry on a fit check. A fit check is a good check to ensure the respirator, which has been fit tested, has been properly positioned to the face, and there is a good seal between the respirator and the face. So the fit test is to test about the efficiency of the respirator, and the fit check is to check whether the respirator is good, is the tight fitting is good, or whether the worker is under the good method to put on the respirator. So the fit check and the fit test is very different. So how about the fit check? And how to perform a positive pressure fit check? This is a positive pressure. So place your hand over the acceleration valve, then exhale and observe if the mass inflates. And this is the positive pressure. So you can put your hand over the acceleration valve, then exhale, and observe if the mass inflates. So for the negative pressure fit check, then place your hand over the inhalation valve. Place your hand over the inhalation valve. Then inhale and observe if the mask collapses. For disposable, this is the disposable N95. For the disposable mask, use both hands to place the mask and then observe if the mask collapses during inhalation or inflates during exhalation. So this is the positive pressure. So positive pressure, you need to exhale. And for the negative pressure, you need to inhale. And for the simplified disposal mask, you can exhale and inhale to see if the mask is to collapse or inflate. So this is the fit test. So we just mentioned about the fit check. This is for the fit test. So for fit test helps to identify unsuitable style of tight-fitting respirators that do not provide adequate protection and should not be used by the individual worker. And conversely, suitable style of respirators that should be used by the individual worker. So there are two methods of fit testing. One is qualitative testing, and one is quantitative fit testing. So for the qualitative fit testing, is suitable for disposable filtering face pieces and can be undertaken by a competent person at the workplace. Qualitative methods are based on the worker detecting leakage through the face seal region using a bitter or sweet tasting aerosol or other compounds such as saccharine. This is a pass or fail test only. So this is for the qualitative testing. And for quantitative fit testing, this is the qualitative, and this is the quantitative. So for the qualitative, we use some saccharine for the tester to see if they test some bitter or sweet tasting aerosol. So for the quantitative fit test, so we need to generate some something inside the respirator and need to use some instruments to test the some particulate. So for the quantitative fit testing, this is suitable for half-pressed respirators or full-face respirators and PAPR and gives a numerical measurement of the fit. Specialized equipment is required to conduct the measurement, which typically involves a laboratory test chamber or a portable fit testing device. This is a more stringent pass-fail test. So this is a pass or fail test and more stringent. This is a test-fail test, and this is a test-fail test. For this, is only for the tester to test the sweet or bitter aerosols. And for this is to generate some particulates inside the respirator and to use some numerical measurement instruments to measure the particles. So this is also a fail pass or fail test. So this is the respirators. So how to storage the respirators? So one respirator should be prevented from any physical damage or chemical contact or dust contact or sunlight exposure or extreme temperature or excessive moisture. So we many times it should be kept in a store or kept in a plastic bag, and to prevent the respirator to contact with some outer scenarios. And respirators for emergency use should be clearly labeled with user instructions and stored in adequate accessible places. So I just want to uh, uh, so for the storage of respirators, sometimes we store the we need to use the respirator. If they do not use, they are not good. So, but also we need to take care of the storage situation, and we need to take care of the steps to store to store these respirators. So it's quite a dilemma. Finally, we will introduce protective clothing and hand protection to conclude today's lesson. The following are types of protective clothing we often see. So it's level 1 assemble, and level B, and level C, and level D. So this is a very quite common protective clothing we often see. And first, we introduce the lab coat. So the lab coats are required when staying in the laboratory, handling or storing chemical. And lab coat should be removed immediately if contaminated. White coat I prefer and should be kept clean. So you can see normally it's white coat. Why? It's just because it's very easy for us to see whether it's clean enough. So if it is not clean, we need to change it. So long pants and closed shoes of low heel are the preferred personal clothing. Baggy clothes and long hairs are prone to accident in the laboratory. So the following information is sourced from these reference books. You can, if you can borrow it, you can see the reference book. It's very famous book for us to use to choose some chemical protecting clothing. So just like the gas cylinder, you have they have some color coding recommendations. So why? It's just because the color is very easy for us to take a notice of them. So for the red color, we usually think it's quite in a emergency situation. So if you see the gas cylinder, if it is paint red, so it's hydrogen. So hydrogen is very flammable and have some explosion, some potential. We normally use the color coding to help us to make a decision. So in here we use this book use the color coding recommendation for us to be easy to use to choose some to follow these guidelines to choose some protective clothing. So for here, so if for green light is a recommending you can use the clothing for over 8 hours, and this for the white is not tasty, so you can use this to choose. This is a very good example. So I want to give you a detailed introduction about the death of Dr. Wetterhand. So in 1997, Dr. Karen E. Wetterhand died from mercury poisoning resulting from a single exposure to dimethyl mercury. Dimethyl mercury. It's almost a year before. So a year before, Dr. Wetterhand exposed to the dimethyl mercury, and after 1 year, she died. Her death raised numerous questions as to how this tragedy occurred and what could be done to protect against a chemical as dangerous as dimethyl mercury. So the photo below is related to the effects of hydrofluoric acid on the human body. So the exposure of skin to hydrofluoric acid. So you can see the nail, the finger. So it's become to rupture. This is the commonly used laboratory gloves. So cotton and asbestos gloves used for heat protection. These gloves are sometimes coated with aluminum oxide during manufacturing to provide chemical resistance and waterproofing. And second is the plastic dipped gloves used to provide protection when handling chemicals or grease. And third is the leather gloves. Leather gloves used to provide protection during welding operations. And the gloves supported with metal mesh used to prevent fingers cuts when handling knives or sharp objects. So this is the common use gloves. So regarding the protective effectiveness of gloves, we can refer to the guidelines provided by the manufacturer. And generally, we can select the appropriate gloves based on the glove resistance to permeation and degradation performance rating. So this is the graphs you can use to select the plastic gloves. And this is the index about how to select the gloves. And this is about the hand protection. Some cautions you need to know about the gloves. So we don't have enough time, so I just want to give you some information about this. And most important is this. And how to remove the gloves. So to protect yourselves, you need to use the following steps to take off gloves. This is the 4-step gloves, but actually I will recommend you to use the 6-step glove, 6-step to how to remove the disposable gloves. So for the step 1, integrate the outside of one glove at the wrist. Do not touch your bare skin and peel the glove away from your body, pulling it inside out, and hold the gloves you just removed in your glove hands. And for the step 2, peel off the second glove by putting your fingers inside the glove at the top of your wrist. And for the step 3, turn the second glove inside out while pulling it away from your body, leaving the first gloves inside the second, and dispose of the gloves safely. Do not reuse the gloves. And the fourth step, clean your hands immediately after removing gloves. So you need to follow these 4 steps and not to use your bare hands to touch the gloves. So this is the right steps for you to remove the disposable gloves. So finally, this is the slideshow was compiled and edited by Champion Chen of Department of Occupational Safety and Health. It's a China Medical University based on the information originally presented in the following teaching materials. We need to thanks about the CCC, the teacher. So this is the all of our case. Thank you very much.